Hello and welcome to my flight. I'm Thomas. I'm going to be the pilot flying the Airbus A340 311 from this flight from Zurich International Airport back to Zurich International Airport. I'm going to fly flight level 250 to Mach 0.86 maybe, or higher speed, but probably 0.78 SAS. We're gonna fly level 250 or 35,000 feet, and the flight is gonna be perfectly normal. And we're now in the cockpit for the preparation for takeoff. And I'm going to be explaining you some of the Airbus A340 systems while we do this video. So here is the cockpit, as you can see. Um, you can see here the flight controls, the side stick we use for the flight controls. I move the flight controls with a side stick by moving left, right, up and down to turn to actually control the flight spoilers in the wings and the ailerons, and also to control the elevator position for pitching up and down the nose for climb and descend the aircraft, as you can see here. Well, here is the engine throttles, the throttle lever. We can move the throttle like that and increase the engine thrust, as we can see. The thrust is building up. Now it's in the takeoff go around dead end. It's like 86.4%. The exhaust gas temperature, then 1, which is the front fan, the rotation speed of the high speed front fan. This is the exhaust gas temperature, 821 degrees Celsius. This is the N2, which is the low speed compressor, the high pressure compressor, which is the N2 94.2. And this is the fuel flow in liters per hour, which is 11,660 per engine per hour. Actually, the N2 is the high pressure compressor. I made a mistake before, and the N1 is the low pressure compressor. We have fuel on board 70,260 pounds. Flex terminal set configured takeoff and here we can see this is the ECAM display, as they call it. The upper and the lower ECAM in the Airbus. The upper is for showing, for displaying the engine parameters all the time. You cannot change this, and some other parameters there, like the fuel on board, and some takeoff inhibit, parking brake, some settings we do, or some failures we have in flight, for instance. And this is and displays this in yellow, actually, like warnings, and red in failure. And this is the lower ECAM, electronic centralized aircraft monitoring display, which displays all the aircraft systems, like you can see additional engine. You can see the fuel used per engine right now, which is 510 pounds per engine. The oil quantity, which is 16.5 quarts. The PSI, which is the pressure in the engine, which is 44 PSI. The temperature, 130 degrees Celsius. The vibration, which is 1.2 inches for the N1 and 1 inch for the N2. And the nozzle, the NAC 146. This is the nozzle, if I remember quite well. Air temperature, 146 degrees. The gross weight is not displayed right now. Gross weight center of gravity 29.5%, and we have the total air temperature and the saturated air temperature, which is 12 degrees Celsius right now. You see additional system like the bleed system, which is from the engines, which supplies bleed air, compressed air from the engines into the other systems which need compressed air, like the cabin pressurization system for the aircraft, and maybe some hydraulics uh, pumps which need compressed air, and the air conditioning. We have supply from each engine right now. Engine 1, engine 2, engine 3 and 4, and we can see it up here actually in the overhead panel. You can see the overhead panel over here. The blade system, maybe I can change this view, it's gonna make it better. We have this view over here for this system. Okay, here we have the cam display, which I pop out, and here's the air system panel over here in the overhead panel. The electrical, the fuel, and the fuel, the hydraulic, the fire, the others, which is air data inertial reference system, the a backup RMP, radio management panel. Here we have the flight control computers. We have some additional flight controls, which is the prime and the prime one and the second one over here. And here is the prime 2, prime 3, and the second 2 over here on the right side. I don't have the time to explain everything in one video, so we're gonna make another one. Here you can see the engine 1, 2, 3, and 4. You can see I can trim up and down this wheel actually, which trims up and down the elevator, the horizontal stabilizer, trim up and down for balancing the aircraft in flight. You can see the flap lever over here. So flap 1, flap 2, 3, 4, and here is the speed brake lever. I can show you. I should get back in the. Here's the electric actually. Maybe if I turn this on. You can see here if I'm gonna change this to the electrical, for instance. This is generator 1 supplying generator 2. It's actually 4 generator from its engine, one from its engine supplying the aircraft. External A, external B, and C, alternate current essential, as they call. If I'm going to turn off a switch here, it's going to turn off in this display, in the ECAM display also. Right now, here. And you can see the lights go off because generator 1 and 2 is off right now. You can connect this back. We have electric power again all over the aircraft. And we can see the generator 1 and 2 percentage of output, if I remember well, 48%, 115 volts, 399 hertz. Integrate drive generator 1 and integrate drive generator 2, temperature 124 degrees, temperature 123 degrees. We can see here is the direct current electrical, which is used for battery 1, battery 2 and APU battery. We can see the APU transformer rectifier here is not connected right now because the APU is off. So I'm gonna turn on the APU. This is the auxiliary power unit, which supplies electrical and pneumatic power and hydraulic power to the aircraft when the engines are not working. It's also used for the engine start. So you're gonna see here now it's gonna start supplying the DC APU transformer rectifier. When the APU is ready, is running. You can see the APU here. Flap open. Electric. DC APU TR. APU battery. Off. Here. We turn off this. We have it back. And maybe we should try see, and here is the pressure for pressurizing the cabin of the aircraft, which uses the pneumatic, as I told you, from the bleed engines or the APU most of the time, or the rammer in case of an emergency. And if we turn off this, the bleeds here, we're gonna see the bleeds are off also here in the display. So I can use the APU now for supplying. You can see the APU, the line is on. I turn the light on here, the switch, the APU switch. You can see it off here and on. I turn the engine blades on again in the on position. External APU generator. Wait. So I'm gonna use the electricals again. If I'm gonna turn off the batteries, battery 1, battery 2 off, so we have no direct current from the batteries. And I'm gonna turn the generators off also. We should be having from the APU some electric. Now I'm turning off the APU, but we have no electrical power. So I'm turning the APU generator again on. So I'm gonna show you this. The supply from the APU in terms of electrics. And here we have it. We have batteries off, we have generators off from the engines, but we have electric power from the APU, which can supply the whole aircraft. Okay. Here we can disconnect the integrated drive generators with this red cover switch, which it should be not done during flight. It should be done only ground. Because if it is disconnected, it cannot be connected again. In flight, it should be done by maintenance in the ground. And here we have the fuel panel, hydraulics, fuel. We're gonna have fuel on board. Here's the fuel on board, 70,000 pounds, which is 35 tons. From its tank, wing tank, and the center tank, which is empty right now. So we have 31,000, maybe 32,000 pounds, 33, yeah. It needs a wing. We can see the pumps are working and are on for its from its wing tank. left and right. There are two pumps that supply engine 1, engine 2, engine 3 and engine 4. Two pumps in each wing, and there is a cross feed also. So if I'm gonna turn off the standby here, you can see that the fuel panel, I'm turning off. The standby, there are two for safety reasons, the standby and the standard. So I'm turning off the standby, and you can see them in yellow and they are crossed. So I'm turning them on, and again they're green and they're vertical. If I'm gonna turn the X feed here, now the X feed is on, is open, as you can see. So you can supply each engine from each tank using the same feed line. This is done in terms of fuel imbalance in the wings or some kind of failures, and turn them on for its wing and its engine. You can see the avail here. This is for transferring fuel in the trim tank in the tail section of the aircraft. You can see the feed here, which is right now it's in the auto position, I think. You can change mode. This is forward. Now we supply fuel forward from the trim tank. We have 3,000 pounds here. You can see in the tail of the aircraft. We supply it forward. Left, right, we can turn them off. This is for the center tank. We have no fuel there, so we can turn them off anyway. And this is for transferring fuel from the manually from the center tank back to the trim tank of the tail. This is done to balance the aircraft in flight and save fuel, having some extra fuel in the tail. We can turn this off back to the automatic mode as it was. So the air pressure here from the engines, the electrical, so you can remember everything. I show you the fuel. Now I'm gonna show you a little bit the hydraulics here, the green, blue and the yellow, which is one from each engine. We have 4 engines in this aircraft, and there is also an electrical backup for each engine that supplies hydraulic power to the aircraft system, like the hydraulic controls, like the flight controls that moves the spoilers, the ailerons, the elevators, the rudder, the horizontal stabilizer, also the reverse thrust and the speed brake and the nose wheel steering and the landing gear, and maybe many other systems I don't remember right now. So we have it here in the hydraulic. What is it? Oh, here, the hydraulic power. You can see it over here. There are 3 systems, one for each engine. Engine 1, engine 2, 3 and 4. Engine 1 and engine 4, one in each wing, uses the green system, as they call it. It's much like the Boeing 777 in the Airbus A340. We have the blue and the yellow. Blue is for engine 2 and yellow is for engine 3. Each one supplies a different control surface of the wings, or the horizontal stabilizer or the vertical stabilizer, like the ailerons and the spoilers I was telling you, and the elevator and the rudder. If we turn this off, we can see the electric should be turned on actually, in terms of this. Yeah, here we have it. This is the electrical, this is the engine, yeah. we can turn off the engine hydraulics like that by lifting lifting the cover and turning them off. You can see two of them are off right now. The green of the engine number 4 and the yellow, and also you can see the electric in the 1 and 2 are still working. I don't know why I cannot turn them off while I'm trying this. Oh, nice off. So we're gonna have all engine hydraulic pumps and generators off. All of them off right now. So they're yellow and displayed in yellow, and they're crossed. And you can see the pressure here in PSI is falling down from its system. It's 0 right now in the yellow, and it goes down for the blue and the green. So I'm gonna turn them on again. You're gonna see now it's building up again. How fast is supplying the pressure, the engine. They call it actually there is a drive box in each engine that contains these hydraulic pumps. You can see them on again. So this is it for the overhead panel. We also have the flight controls computer. Here's the landing gear, the flight controls. This is what I was telling you about the hydraulic system and the flight computer. I'm gonna explain it in another point. Here's the yellow and green, green and blue. You can see supplies the ailerons. You can see the ailerons moving right now. Here is the elevator. The elevator in the tail of the aircraft is moving up and down. You can see it here in the display, in the ICAM display, as they call it in the Airbus. Here you can see the rudder is going right, left, right. Okay, that's because we have hydraulic power, and the prime computer 1, 2, and 3, and the second computer is also working. And here we have the speed brake extend. I think we have flap display. Oh no, maybe not. Oh, we have it over here only. We have a different computer for the spoilers and flap control computer, as they call it, the slat and flap control computer. So I'm gonna turn on again this and come over here and maybe make a quick flight. You can see the aircraft here. We are at runway 14 international. So we have a, you can see the engine thrust reversers here deployed. This is the speed brake, slow down the aircraft. So I'm gonna turn this view here. Here we have the overhead panel. I'm gonna turn on some lights maybe. The anti-ice here, we have to turn this on for the wings and the engine. And probably external wing strobe on. Logo on. Integrity. We have some lighting here. Let's make it easier. Here you can see the engine dentants as we move the engine throttle level. Here we have it in manual, climb, flex and city, and takeoff go around. And we can see that displayed over here. Takeoff, flex. Manual MCP, thrust climb, and thrust lever. We also have this is called the primary flight display, which I'm gonna be showing you in another episode. And maybe we're gonna start the engines here. Maybe I'm gonna try this. Okay, no, need some lights here. I'm gonna set up a flight plan here in through this the flight management and guidance computer, as they call it, FMGC. Fuel prediction. It should be having like fuel 70,000 pounds pretty much. They're not letting me change this, so I'm gonna turn this from here. Cost index of 100. Cruising flight level 250, 25,000 feet. Here we have something in the navigation display, as they call it. We can display the waypoints around us, around the airports. Maybe some waypoints. Oh, here we have it. We had some delay here. We have the airports right now been displayed. We have other also displays, but not this simulation. For this mode navigation display. We have more in the primary flight display. We have the autopilot and this kind of like instruments. So I'm gonna show you how to turn off and on the engines. Maybe we have the APU on, so we can actually turn each engine off in the off position. You're gonna use as they call it the engine master switch here and the engine start lever. So I'm gonna turn them off. So we have no fuel supply in its engine now. All engines are going out. So you can see them here not working. So I'm gonna use some, I need pressurizer from the APU. So I'm gonna turn this APU on, and the engine bleeds off for the engine start. And I'm gonna use close the bleed, because I'm gonna start maybe not up, close. Okay, there. And here's the electrical. We have the APU on, the battery's on, the electric generator's off. We don't need X-feed, hydraulics. Okay. So I'm gonna turn off this switch on engine start. Gonna turn this on the ignition position, the other side, like that. Ignition start, and it's going to initiate the process. Actually, it's gonna start the FADEC, as they call it. There is a FADEC in its engine, a dual channel full authority digital engine control, as they call it. So we're gonna start this its engine right now. Engine 1 and 2, we can start. Engine 1. You can see the pressure here building up, because this initiates the engine starter, which pressurize the high pressure compressor of the engine, turbofan engine, like a jet engine. Here we have it. The engine is start, because it's the fuel levers is on right now, and it's supplying fuel into the engines. Engine number 2. Here we have N2. You can see how it's building up the N2, which is the high pressure compressor, the engine starter, and then the N1. The fuel flow is 200 pounds only right now, so it's gonna be 2,000 pounds very fast. And the temperature is increasing quite rapidly. And now we have the N1, the front fan, the low pressure compressor with low speed compressor. Here we're gonna start now engine number 3. We're gonna turn this on here. We can turn it open or in the auto position, which is the isolation valve for its wing bleed system. So we can use the bleed from the engines, I believe now, from the left and 1 and 2 engines. We have engines 3 and 4 off right now. I'm gonna start engine number 3. You can see here this symbol means that the system, the FADEC, is actually initiating. So I'm gonna start engine number 4. Now we have all engines working, so we're gonna turn this in the normal position, like 1 minute from now. We no longer need the APU bleed here, so maybe we're gonna turn this off. but it doesn't really matter. It's off anyway. It's automatic. So we're gonna turn this engine bleeds 3 and 4. Now here we have the Airbus A340 is almost ready for takeoff. So maybe I have to do this